you basically about how to just like drop JavaScript and just use Lisp all the time. Hi, my name's Kat. I'm one of the devs on the NPM CLI client. I'm also kind of a programming language theory nerd. And I'm here to give you a bit of a history lesson. A lesson about one of the aspects of JavaScript that sets it apart from just about every other language being used at its scale. Prototype-based object orientation. He basically gave my talk for me, come on. So, y'all are at a JavaScript conference. I'm sure at least some of you have heard this term before. Others might be familiar with people talking about just OOP or object orientation. But what is this whole prototype thing? Well, since there's probably more people used to class-based languages, I'll explain it in terms of that. Think of it this way. The object-oriented stuff most people are used to involve class definitions. So classes are, you can think of them as blueprints. They define the behavior, the structure and behavior of objects, and then you create a bunch of similar objects based on that blueprint. Like in this Ruby code here for creating a dog with a name and a bark method. I'm not going to apologize for putting Ruby code on a JavaScript conference. Now, when you want to create a new kind of object, you must first create a new class, and then you make a bunch of other instances from that definition. But you always have to define that extra class, and your objects are always disconnected from that class itself. Now, prototypes are different. In prototype languages, you don't have any classes. You just make objects that could even work entirely on their own. Here's an example of a dog. It's just called a dog here, and it has a bark method, it has a breed, and hey, look, you can use that dog just by itself, right? Cool. So if we want a more specialized kind of dog, we just clone our dog prototype, specialize only the things we need to be more specific about, and we start using it right away. This mechanism where clones are able to reuse their parents' code is called delegation in prototype languages. In this case, Dogen is using the bark method from its parents, but we can customize the name and all that stuff. So why am I talking about this? Because JavaScript is very much a prototype-based language. Anything we do with objects with JavaScript always goes back to the behavior of its prototypes. Horse.js is also pretty excited about this. There's a reason JS is pretty great, and that's prototypes. And this bears repeating. JavaScript has no actual classes. All this stuff we use, like constructor functions, are just a little bit of sugar over the underlying prototypes. Here you can see I'm reusing the old dog prototype, the one that we defined before, just by setting it on the constructor function, and then the new mechanism takes care of that, and that's just sugar. Even the new class syntax is just papering over those prototypes, just to give folks something more familiar. But believe me, you're always working with prototypes, whether you notice them or not. So why does this distinction matter? Because prototypes have always been about interaction, flexibility, and play. They've been about creating programming experiences where the way we interact with our programs feels more tangible. And it's closer to the objects in the real world that we want to try and model. I know this might seem kind of abstract when I say it like that, but I hope as we go on, this ends up making a lot more sense to you. But anyway, this talk isn't about the mechanics of prototypes. This talk is about how this whole concept came to be, what ideas formed it, what we tried, what worked, what failed, what changed. It's about understanding why we did all this. This talk is also about the future, because there's so much that our past can teach us about where we can go next. Now, when it comes to prototypes, their story begins about 40 years ago with a little language called Director. As far as I was able to find, this is the earliest language that was recognizably prototype-based. It definitely didn't call itself that. It was trying to be an implementation of one of the really, really hot new ideas at the time, something called the actor model. Now, the actor model was this way of working with concurrent applications, so parallelism, multiple processes, threads. The gist of it is you have these things called actors, which are kind of objects. Usually they're attached to some thread or some process, and you have them send messages to each other. For example, we have Joe Armstrong here. He's sending a message to his good friend Mike Williams, who will receive the message, interpret it, and usually take some action based on it, assuming it actually gets the right actor. Wow, tough crowd. You might have heard of the actor model before in terms of a language called Erlang. From here, it's from here. Which has ended up being kind of like the standard bearer for the whole concept. But Erlang actually came much later than this. And I kind of really wanted to use this image. So going back to director, the language was written as part of some early work in computer graphics. As an implementation of the actor model, it used message passing for its operations. There was this ask function you could call on objects. It's just a function. And that would send messages to them. These worked just like you might be used to. Actors would respond by just running code for that message when they received it. Director also had an async event loop you could essentially schedule things into. It wasn't parallel, and it was actually a lot like JavaScript's current event loop. Finally, this is the first example I could find of delegation-based inheritance. So in Director, you made new actors by cloning existing actors. When you sent a message to that new actor that you just cloned, it would try and answer the message itself. Now, if it didn't have its own response registered in the object, it would take that message and pass it on to its parent, like the parent that got registered. If that parent didn't have it, it would keep sending up the inheritance change until it ran out of parents, and it would either call the message or fail. Delegation turns out to be like one of those really core principles of prototypes, and almost every single prototype-based language since has used the semantics for inheritance, be it for properties or for methods. So what did Director look like? I told you it was a Lisp thing, right? Here's some example code. Just like a lot of other language experiments of the day, it was written on top of Lisp. So Director was designed for computer graphics. It used this style of graphics based on Logo's turtle programming. So the idea of Logo was you have this little cursor, right? And then you tell it to turn in one direction or another, and you tell it to go a little bit this way, and then stop drawing and move. And then you end up with a drawing. It's supposed to emulate the way that you would draw on paper. So looking at the code, let's look at the first line here. You can see the cloning I mentioned before. It just sends the make message. So ask movie make. That sends the make message to the movie actor and created a new actor. That's its internal thing. And then when it's done creating it, it assigned that new value to a variable called my first film. So you just have this movie thing in the director world. From there, you can set different draw commands to different actors representing graphics primitives. In this case, we had previously created a star and a pentagon, so that's what we're moving around. You can see like scheduling different moves. So that was the plan. That's what the planned message did in Director. It just sent it to the scheduler. And then at the bottom, we tell our first film to record the next 4 seconds. And when it's done recording, project it, like actually display it. And I do mean play it back. This was a film strip that you'd end up with, seeing on your monitor. Probably not super impressive by today's standards, but this was 1976. And this was a really high-level way of defining animations like that. Anyway, that's Director. It would take a few more years before we stopped talking about actors when it came to semantics like these and started calling them prototypes. OK. And this brings us 9 years later to a language extension called Object Lisp. Now, this was the first instance I could find of a prototype-based language that wasn't just calling itself actor-based. It was a language extension for Lisp used mainly in Lisp machines by LMI. Now, Lisp machines were these big old computers with a special architecture that did a lot of Lisp operations directly on the metal. Like a lot of regular Lisp functions, we just run in the architecture. They were popular with some researchers and AI folks in the day. They also had these operating systems that let you manipulate running programs and even change the behavior of the OS itself with some interactive Lisp scripting. So they were very, like, you really got hands-on with this operating system. Now, Lisp machines used Object Lisp heavily for their UI work. Again, we see prototypes being a really nice fit for interactively building graphical applications. As far as I can tell, no one at this point, even now, was calling anything prototype-based OOP. Object Lisp just called itself object-oriented, and it used that to like differentiate itself from class-based systems of the day. So it was like, what are you talking about? You're not object-oriented. We're object-oriented. You just use classes. And And even so, it really felt a lot more like class-based system than its earlier actor siblings. You're not creating any actual classes, but you'd still write these like very class-like prototypes that weren't used for anything but making new instances. So it meant folks, used to class-based systems would have an easier time learning it. Sound familiar? So here's what some code looks like. This machine is huge. This is a little script written using object Lisp to give you an idea what it's like. First, you can see the first thing, it defines an icon prototype. It assigns the new random object to the icon variable. Then it adds a method, defines the method goToXY to that prototype with this deboff function. Going down a few lines, we see that it clones that icon prototype using kind of, that is essentially the object create. And in the end, you just call that method. So aside from the parentheses, I think this would be not too foreign to a lot of people here, especially when you put it side by side with JavaScript. First, we create a new instance of graphics object, then we add a goToXY method, then we use object create to create a new icon called icon1, which delegates the original icon. Finally, we call that prototype's method on icon1, and it goes up the inheritance chain to call that method. Now, looking at stuff like this is a big part of why I really love language history, because we're still using pretty much identical semantics in 2017 than what some folks were already using in production more than 30 years ago. I think some folks think about that and feel like we've just taken steps back or not evolved. But to me, it feels really validating that the thing that we use every day is actually this solid. Anyway, mentioned 30 years ago. Let's go to exactly 30 years ago. Happy birthday. I'm sure folks here have heard of Self. It's probably most famous for being the first fully prototype-based language. A lot of people just consider it the first prototype language. To this day, this is probably one of the most important and innovative dynamic languages in the history of programming languages, not just for prototypes. So Self was a research language at Xerox PARC, which was basically like the Skunkworks R&D department of Xerox at this time. An incredible amount of cool stuff just poured out of here, that we just take for granted these days. You had laser printers, bitmaps, the GUI, the mouse, Ethernet for local networks, Smalltalk, and the model view controller architecture all came from this one group. And that's a lot of work for a group. So Self came out of this amazing place as something built on top of Smalltalk, except instead of classes, it would use prototypes. And prototypes, as it turns out, and as we keep seeing, were particularly great at graphical work. Self doubled down on this, making the entire development experience based around manual interaction with actual objects. So you want to have a new type of green ball, you just kind of click on one of them, clone it, and then just start changing the code on that new clone. There was no need to do the individual class definitions you'd have with Smalltalk, and the user experience of building applications by clicking on things was just so much smoother. Now, just like Smalltalk, Self had no source files. The way you wrote applications was literally by running this program in a window and clicking around and creating new elements and dragging them around, and you had these little text boxes for method definitions. But you didn't have this whole architecture. You didn't do any of this building or Git stuff or any like that. As it turns out, having all this graphical stuff and dynamically typed objects and using delegation wasn't exactly the fastest thing ever, especially not in 1985. So in order to get their UI to run smoothly, the Self devs put an immense amount of effort and research into making prototypes go very, very fast. Some of this optimization work had already been done with Smalltalk, like inline caches, but even at that level, Self had a lot of special needs because of the dynamicity of the system. Now, the whole point of this was to have their cake and eat it too. All the ease of using a very dynamic system, but with speed to match lower level languages, and they really did want to match lower level languages. They really delivered on it too, and many of the optimizations that Self pioneered that day, during that research, ended up being used years later by JavaScript engines, especially V8. So Self put a bunch of effort into exploring the semantics of the concept of prototypes. They played around with different types of inheritance, including multiple inheritance and traits. It played around with semantics for properties, and it took all of this stuff and published a bunch of papers on it so future generations could benefit from it. Of any of the languages I'm going to talk about today, I think it's safe to say that Self had the single biggest influence on modern JavaScript than any other language. And I think there's like a ton of inspiration we can take from it even now. Yeah, this is like the bibliography page on the Self language website. So let's do something a little different. Instead of graphics, let's talk about this cute little language that used prototypes for really creative things in a text-based world. Now, LambdaMOO was both the name of a programming language as well as the game that used the language to build this really cool little virtual world. How many of you here are familiar with MUDs? Wow. How many of you have actually played MUDs? Hey, this is so great. So, for the rest of y'all, MUDs were basically the precursors to MMORPG games, MMO games. They were online, they were multiplayer, they had a bunch of players in this shared world, and they were text-based. You literally went into your terminal, used Telnet, and connected to the central server, and then you could have this thing that looked a lot like a text adventure, except you could enjoy it with friends. The acronym itself stands for Multi-User Dungeon. So, LambdaMOO was one of these, and it was founded at Xerox PARC by someone in their language research department 3 years after Self first came out. So this was very much connected to Self. Now, the thing that really set LambdaMOO apart at the time was that it allowed players themselves to make or modify any object in the world. A player could log on and start adding rooms to this increasingly large universe that they kept building. They could customize their gear or their characters, and most importantly, they didn't have to be experienced developers or even part of the wizard or dev team to have permissions for it. Let me walk you a little, really quick through a basic LambdaMOO session, because it's kind of fun. So the first thing you do to play a MUD is connect to it. We'll use Telnet in this case. This is just like a log from a terminal session of mine. I actually installed LambdaMOO, like a basic version of LambdaMOO on my machine. So this is exciting for me. So once we're connected, you'll see we're dropped into this first room thing. There's not much else in the game because we haven't built it yet. So let's build something. First thing is we dig out a room in the north with the @dig command. We'll call it Nobelberget, which I hope I didn't just butcher. And that's it. We've created a whole room now. The number is the little number you see is the unique object ID, because every single object in LambdaMOO has a unique identifier. Then we type north, which if any of you have played text adventures, that's just kind of how you move. And it doesn't have a description. That's what this you see nothing special is. So let's give it one. We use the @describe command, set a description for it, and then we look at it, and we have a conference venue now. I bet, you should have hired me to do this for them. So let's move on to putting things inside that room. @create creates a new object, here called audience. The $thing argument here is the prototype. We're basing the audience on a generic $thing. Again, we see it, we give it a description, just like with the rooms, and we take a look at it. Finally, we use this @verb command to add a verb, and @edit to change the code on it. Now this, I'm not showing you the session, because this was basically dropping into ed. That took me a while to figure out. It's like, how do I exit this thing? Control-C, Control-C. No, I want out. Anyway, that's it. By the end of it, you have this little verb that I just added to the entire game, and anyone else in this game can entertain the audience. You're all great, by the way. Thank you! That's what the experience was like, right? There's a full programming language, and you can use that if you want. But if you're just a player, if you're just a hobbyist, you can log in, and you can have this whole experience. You can express all this creativity. I know friends who just spend days and days building new rooms because it just allowed them so much freedom. Now, I know I was talking in past tense, but it's now 27 years after it launched, and it's still running. And it still has a bit of a community, not to mention a small ecosystem of alternative servers with their own custom worlds. Last I looked, there were about 50 people online in the main LambdaMOO server, which is actually pretty respectable for a small mod these days. Anyway, check it out. You can totally play this right now if you want. So we're mostly done with ancient history at this point, I swear. We've got 2 more languages to talk to you about. And they're both still in widespread use today. They're both from around the same time and turned out to be really similar. The first is Lua. Now, Lua isn't an acronym. Don't say it's an acronym. Don't capitalize it. It means moon in Portuguese, and it was created by members of something called the, the Computer Graphics Technology Group, TechGraph, at the Pontifical Catholic University of Rio de Janeiro. Which is a mouthful. Now, see, at the time, there were a bunch of trade barriers for importing software to Brazil. And so they either had to fork over all this money just to try and import things, or they could try and write their own, and then I ate shit. But writing your own versions of things is kind of a big pain. So what can you do? Well, you can try and use a scripting language, because scripting languages, they might not get you a lot of the performance features and maturity of some of the lower level stuff, but you can get a lot done in a short amount of time. So they looked at Tickle, and it didn't really tickle their fancy. They really liked Lisp, which is a great opinion. And they hated the syntax, which is a really bad opinion, and no one should have it. Finally, since this was going to be used for computer graphics, it needed to be both fast and it needed to be embeddable. That is, it needed to play nicely with the lower level C and C++ code for the most performance-sensitive bits. Self was also like 32 megabytes just when it launched. It was not a light language. So this is what we ended up with. Lua called its objects tables, and it ended up doing inheritance through something called metatables, which it literally is just a prototype chain mechanism. It's really fast enough that it ended up getting like widely adopted by the games industry, which, as you can imagine, they really, really like performance. So they loved using this for their game logic scripting. It kind of became the de facto standard for a while. Now, by this point in time, we've seen prototype languages go back to something like objectless semantics from years back. In fact, this Lua code that sets up a 3D vector prototype maps almost directly to how you usually use it in JavaScript. The main difference being that setting up metatables involves like a little bit more work, but that's like not such a big difference. Now, as I mentioned before, Lua is still in wide use. It's a cute, fun little language that really shines in the area that it was designed for, much like the last language I'm going to talk about here. The one this conference is all about, JavaScript. Now, at this point, we've covered about 20 years of history, and I don't have a lot of time left. And by now, JavaScript is about 20 years old. And that's kind of mind-blowing. Like, we're talking 40 years of history here. So what is this JavaScript thing? And what did we learn from it? Well, first of all, it's the most widely used prototype-based language in the world. Based on some statistics, there's now more code written in JavaScript than any other programming language in history. And that's a pretty big deal. Now, JS was created by Netscape as a scripting language for early web browsers. They literally just wanted to move pictures around in a web page. It's like, that's the cool thing those days. Now, they did have some requirements for the language. JS was born right into the first browser war, where different vendors were competing with each other for, like, really aggressively for market share. And any tiny small edge and features could push you right past the competition. There were 2 big constraints here. First, it needed to be easy to learn. Second, it needed to be written very, very, very quickly. The first prototype was written in just 10 days, which is kind of incredible. And it was basically this cobbled together version of Scheme, Self, and I don't know, they just kind of slapped Java syntax on top of it, and they named it JavaScript because Java was the popular thing, and they kind of wanted to be popular, and they liked Sun Microsystems, and that's pretty much it. That's how our beautiful, problematic child was born. Even so, it's pretty great. It's grown a lot in its 10 years since that 10-day prototype. Prototypes turned out to be a really good match for the DOM and the platform in general. The goal of being easy to use worked out great. JavaScript ended up ushering an entire generation of programmers into this new web dev platform. There's a lot of you right here, probably. Like, so many of us just learned to program by opening up an HTML file and playing around with things until they sort of kind of worked, and then just writing these crappy little scripts. And it's 2017, and I'm still writing crappy little scripts and hoping they work. We also have an actual standard for the language now. And for the past few years, it's been evolving aggressively, incorporating features of other languages and doing its best to keep up with the times. Now, JS might be 20 years old, but it's most definitely a modern language in 2017. So that's it. That's my little overview of how we got here. Now, where do we go from here? How can we take all these history lessons and apply them to the modern world? Well, for one, it's a really great idea, I think, to go back to emphasizing interactive development. This is really where prototypes have always shown. As ES Next starts making it into browsers, I hope like the need for tools like Babel or Webpack, it starts disappearing, and we can focus more on interacting with the platform directly. That also means continuing all the development going on with browser's dev tools. These are really, really great descendants of the self tools that got built back in the day. Now, with ES modules, new live binding exports, you have a lot of opportunity to really make your platform interactive. Finally, I really like web components. I think they're like a really great way to go. React isn't too far from that. You're going to have like Mars's talk after the break, which is going to be about the way to do React components. Kind of continuing down that path, it's really important to keep JavaScript easy. There's this self-paper called The Power of Simplicity that really drives this point home. Simple, easy-to-learn languages help adoption, and they help you do more cool things. And it's up to us to help do everything we can without piling layers of complexity on top of what we're trying to do. The web platform is essentially a little operating system too, and it has all these like simple APIs that you can just access that are much easier to use than their native ones. Let's keep up with the immediate results thing, and check out glitch.com because it lets you like do a lot of that play stuff. And I am running out of time, so I am going to tell you to check out our XJS and the talk that David's going to give tomorrow. Try object.create more. Try out more compiled to JS languages like Elm. Teresa's going to give you another talk about Elm later, and that's going to be really exciting. So that's it. I hope you all got some interesting tidbits from this talk. They say that those who learn history are doomed to repeat it, but I think that when it comes to programming languages, repeating it is exactly what we want to do more of, and how we can figure out how we can go forward. Thank you very much, and happy hacking.